So Jihad wants to start a new job. He wants to buy a machine producing a certain item, and he has two options. He can buy machine A, which is fully automated. It has an initial cost of $20,000. It has no operational costs. The maintenance is 1% of the initial investment, and it can produce 1,000 items per year. It has a salvage value of $1,500, and its lifetime is 8 years. On the other hand, Machine B needs an employer to operate it, of salary $2,000 per year, and the initial cost of $5,000 plus a maintenance cost of 2% of the initial investment. In addition, it can produce 1,000 items per year, and the salvage value is equal to $300. Look, I think here there is a typing error. I will fix it here. Okay. The salvage, the number of item produced is lower. So let me fix this.
Professor,
Yes,
how long will be the session?
I will do this problem together, and I will introduce for you the comparison between economic and financial analysis. So maybe 1 hour and a half nearly. Okay.
Okay.
It's 1 second. I don't know why it's not selecting. Okay. So here it's not 1,000 items, it's 800 items. Okay. Now, in the first question, they considering a discount rate of 5%, calculate the CER for project A for selling prices of $4 per item and $4.2 per item, and comment on your results. So first, here we have two options. So this problem will tell us how to decide on, if you want, how to make a decision based on economic parameters. So we have already introduced several economic parameters that can help us into studying the performance of a project. The main ones are the CER and the internal rate of return. These two factors are really important, and in general, the larger the internal rate of return, the better is. And of course, the larger the CER, the better is. But when we compare two projects, okay, in case we have contradictory results, and the CER of A larger than CER of B, but IRR of A smaller than IRR of B, we go to we select the highest CER in general, okay? Unless, for example, the internal rate of return we have a very large difference for IRR, while CER are close, then we can think then that maybe we opt for the better internal rate of return. The idea is in general that both, in majority of cases, if a project is better, it will have higher IRR and higher CER. But in some particular cases that now we will discuss, okay, in case, for example, the income is varying with years, the way, if you want, the net income or I minus CI is not the same, or it's decreasing with time, or the lifetime, if you want, the lifetime also of the project will affect a lot the comparison. So we have a lot of factors that will affect the values of CER and IRR, and based on the comparison between the two, we can come up with a decision which project or which option to select. So to start with, first, they told us to consider project A. We want to calculate for a discount rate of 5%, what is the value of the CER for different selling prices, okay? We have already discussed together in class that whenever we perform an economic analysis, we can consider, like if you want, a parametric study. You know, we can vary we can if you want, sometimes for a certain selling price the project will not perform well, so we can study what is the possible range of selling prices to go over, of course, while being competitive in the market. We can also try to change the discount rate to see in which if you want, what type of investors can be tackled with this project, etc. So, in general, when we do the economic or financial analysis, we don't consider one possible case. We consider variable possibilities for discount rates, variable selling prices, and also we can try to go to other alternatives in case, for example, here machine A. We can see already that the initial cost is really high while the lifetime is relatively low. Okay, so this is why it might not have enough time if you want to give us the returns that we expect. And if it has a larger lifetime, maybe things will be better. So we have a lot of factors that can affect our decision. So to start with, okay, let us see what are the information about machine A. We know that to calculate the CER, by definition, the capital enrichment rate is the ratio of the net present value over the initial investment. And of course, the net present value at which year? At end of lifetime. Okay, so here for n equals to 8. Okay. So now we have NPV at 8 is equal, the general formula is the following. It's minus the investment plus summation from 1 to 8, which is, if you want, the lifetime of the system, of Ri minus Ci over 1 plus I to the power L. Plus, of course, we said that whenever we evaluate the net present value at end of lifetime, should not forget to consider the salvage value. So plus the salvage value at year 8 over 1 plus I to the power 8. Okay, so now once we set the formula, we need to replace our parameters. So first, the initial cost is given. It's equal to income. They said that it can produce 1,000 items per year. And we are investigating two different prices. So first, we need to consider a price of $4 per item. If we case in this case, okay, the income per year, Ri, is equal to 4 times 1,000. Okay, and we have also that concerning the cost, we can have operational and maintenance cost, but they said that the machine is fully automated, so no operational cost. CO for each year I is 0. So we are only restricted with maintenance costs, and the maintenance cost is 1% of the initial investment. So all we have to do is to multiply 20,000 by 1 over 100, which is $200. Okay, so we can say that the maintenance cost, CMI, is equal to $200. Here, what is good, what is relatively simple, is that no variation of income and cost with years. This will simplify our calculation. So now, since this term is constant, 4,000 minus 200, we can take it outside of our summation. Okay, and we can use the formula provided in the course material for the geometric series expansion. So we can replace sum of 1 over 1 plus I to the power L from 1 to 8 by 1 plus I to the power n, which is the number of years, which is 8 here, minus 1 over I times 1 plus I to the power n. I is the discount rate. So here they told us that the discount rate is 5%. Please pay attention, when you replace I, you don't put 5, you should put 5 over 100. So 0.05. Okay. Now for the salvage value, it's given. The salvage value for machine A is $1,500. So we can replace it by its value, and then we can, this is the formula for NPV at year 8. Okay. Now, the only unknown here, okay, we have everything in the formula. So we just have the unknown is NPV at year 8. We can do the calculation and we find out that NPV at year 8 is $5,563.26. Okay. Now, once we get NPV, by definition, the capital enrichment rate is the ratio of NPV at end of lifetime over the initial investment, and we get a fraction of 27.8%. In general, it's recommended for to have a CER larger than 30%. As I told you before, you can higher your expectation to be on a safer side. You can say, I just want to invest if I have a CR larger than 50%. So this is a subjective decision, but in general, we can say that 30% is acceptable. So we are below 30% here. That's why we might try to come up with some strategies to make this project more attractive. Okay. So that's why they told us to try to vary the selling price. Because, we have a certain range of selling prices. We don't have one fixed price. So we can investigate within the possible range. Okay, to be competitive in the market, you can work within a certain range of prices. So you can study the upper limit and the lower limit to see at least if you increase the price, if the CER will be acceptable. So we'll repeat the same procedure now, but we will replace just what will only change is this term, which is the income per year. Okay. So the income per year.
Professor,
Yes.
for any type of project, the CER of 30% is acceptable, all kind of projects.
Look, in general, no, because the idea is sometimes if you have a very long, in general, 30%, they put it for renewable energy projects because they have a very long lifetime. Like maybe if you have a small lifetime, let's say like here, 8 years, you might say, I can accept a lower CER. Okay, so but you don't have one limit that is fixed and that if we have below it it's not acceptable, above it it's acceptable. It's a little bit subjective, but we have recommendations, and in general for renewable energy project we recommend values larger than 30%. Now if you have values, if you have a lifetime that is relatively short, let's say if I tell you in 2 years, for example, if the lifetime